by the corridor. Anyway, the first speaker is Shree sir. Sir.
All right. Sorry for the disorientation for a while. So everybody, can you see the screen? And I think everybody understands what this is, so I'm not going to tell you what it is. All right, so everybody welcome. Very happy to have this hardware Devroom here, which our folks from the absurd community, who are not absurd, have kindly put together, curated. It is very unique experience even for me as somebody who was helping run the conference, because they opted for doing voting. So we have a very nice concept which is coming this time called Devrooms, where communities, independent communities, are actually coming up and actually running the parts of the conference, which is like very exciting for us. Now, keeping my conference organizer hat apart, now I'm going to start talking about my project, which is called Jigita. Now, Jigita is like jump for Kannada, jump in Kannada, and it also stands for Jigita. Okay, so jig is something that people use to help do tasks, mechanical tasks. Itta is like again Kannada for do you have it, right? But by curious wordplay, jig it is also make it a jig, right? That's what you actually see on the video right now. So just as a show of hands, we are in the hardware dev room, but I will ask this obvious question: how many of you actually do soldering? Oh, a lot of people are nice. Okay, so the hardest part and in soldering, actually any manual soldering, is in fact, if you look at it, it's not actually not the act of making the joint. It's actually the task of holding the workpiece in the right place using the 5 or 8 or whatever number of arms that you have, right? And finally, when you're trying to tell somebody that this is how you solder it, actually you're trying to tell them that this is actually you hold it, but making the joint part is basically you take the soldering iron, have the right temperature, make contact with both the pad and the pin, and you put the solder, right? So that's like, everybody thinks like that's not a difficult thing. The difficult thing actually is holding the piece, right? And that's where everybody suffers, and you guys will be surprised to know that not just us, hobbies, people who do it for time pass, business and pleasure, pleasure and business, not only do we struggle, but people in the factories also struggle with the same problem. And nobody is building tools for them. So this is like one such attempt. So this project, which is on GitHub, I'm going to like obscure this for a while. This is the project. It's on GitHub. So how do we describe it? Easy PCB assembly, no motor skills required, right? So most of the time, it's not really about making the joints, it's about. So how do we do that? We do that by building helper jigs. These helper jigs are 3D printed. So again, we'll go back here. The video is a little, it looks very odd. It's quite bad actually. So I'm just going to like take this out. So if you see here, so this is like a Pico, right? So everybody familiar with the Pico? Raspberry Pi Pico, right? So how hard is it to solder this? You'll have to find a breadboard, keep the two things. You could still have the pins like going cross, right? In spite of all of those things, you still have to be careful, right? What this does here is a very interesting piece. Actually, if you look at it, it's like precisely designed to the position of the Pico and to these pins. And it has exactly what you need. Maybe now you can see it better, right? So it has like the exact thing with which you can make this Berg header sit. Okay, apologies for the bad video again. But that's mostly the projector actually. So it has exactly the right thing to sit. And see how easy it is. So you just take this, right? You put this in. You take this, you put it in. And now you take this and you, it's my left hand, yeah, put it in. Now boom, solder, right? So that's how it is. So how was this born, right? So this was born by, actually I do very little soldering. So when I make these kind of tools, people start thinking that, maybe I do a lot of soldering, which is definitely not true. I suck. My eyesight has become bad now. I use my DSLR as a zoom camera for soldering and all that, right? But that's my personal setup. You'll never see it outside. But the fact is, I suck. That's why I made this, right? So I was making one more board, which was this here. It's called, oh sorry. I hope the video does not disorient you guys. So this is a board that I showcased in last year's IndiaFOSS. It's called Ativega. It uses the microcontroller from CDAC. And this very interesting thing about it is it has about like 13 single pin Berg headers. And some of them are 2-pin, there are 8 1-pin headers and so on. And that's a nightmare to solder. And my hardware guy tried to tell me, he said, Shree, this is not how we build it. I said, this is how a software guy builds a board, right? Every interface should be separate. Pins should be logical. I started giving him that long lecture, which I would have otherwise giving him as an architect of the project. So he said, yeah, he smiled at me probably, right? So when the board actually came, guess what I was struggling with? Single pin Berg headers, they won't become vertical. I wanted to sell this board, I can't sell because it sucks. And somebody with my kind of experience doesn't want to sell a board which doesn't look nice, right? So all that happened and kind of, then I started looking at things. I found that with FreeCAD, the KiCad people have actually started trying to do something like this, but they have all never made it very generic. So the key contribution of this project is that you give it a KiCad board, okay, which has 3D models inside it, and it will generate the 3D printable jig for you directly. You have to tweak something to do stuff like, what do you call it, tolerance. So let's say if you use a default tolerance of some 0.2 mm, then the components will fit very nicely. Depending on your printer, there's some dependency, but that's just one parameter that you need to tweak. Okay, you just tweak that one parameter, you have the right model, and boom, you get something which you 3D print, and everything fits like magic. Okay, so it fits that well, and you could do all sorts of things. And well, this is not theory, right? So I've been using it, and feel free to really check out this project. I'll show you some samples. Right. So basically, that's the 1, 2, 3 of this. So there's a video here which makes it easier for you to understand what's actually happening. You have a 3D printable thing which comes out of your design. You insert the components, which in this case are like those 13 Berg headers, and then you insert the PCB, and you are ready for soldering, right? And of course, soldering can't get any easier than this, right? So this is about as good as it gets. So the thing is, okay, so there's a Hackaday project page also, and it can be used in various projects. It's not just, that looks like that's a complicated little project for something like this. But if you really look at it, you will find that you can use it for a lot of projects which are available off the shelf. Now the thing is, I have not designed a lot of hardware. So one of the key problems for me was how do I make sure that this software is good, can work for a lot of people. So what I did is I went around finding community projects. So for example, Pico itself didn't have a KiCad layout at that time. I don't know if it has a KiCad layout right now. But there are community very similar looking footprints, exactly form factor compliant boards. So I used them, and I generated this thing. So it's a script which just runs, and back it will throw a 3D model at you. So there's something called a Pico glitcher board. So that also has a lot of pins, you can see. So they also have other connectors that does it. This is the granddaddy of all soldering projects. Okay, so basically like any interface that you want is there inside this. So somebody's built this kind of a crazy board, and you can imagine how they are going to put it together, right? I tried building it. My software is generic enough to handle it. I've zoomed in and checked that the kind of model it generates is perfect. Of course, I haven't tried it, right? Because remember that involves soldering and getting that board and all that, right? So I haven't done that. Then you can actually use it for doing fun things. So we typically build all these tools. Tools should never be single purpose, right? So what is one of the craziest things that you can do if you have a 3D printer? Well, you do a lot of 3D printing, right? start finding solutions with 3D printing which otherwise should be solved in other ways. Right? So what are the crazy things that 3D printing people do? All sorts of things. Keep running the. You bought the printer, now you have to run the printer 24/7. That means your whole life has to revolve around 3D printing, right? And scheduling the printer so that it keeps running all the time. So in this case, you are into electronics, you're into 3D printing. What do you do next? You build containers for your favorite things to hold them. And containers for what? Bug headers. Right? So you can use bug headers, and well, it's not really limited. You can use KiCad. Use 3D models for Allen keys and build Gridfinity containers for Allen keys, right, using it, and it's all parametric. So it's very interesting, by the way. If you go and see all the Gridfinity, I don't know how many people know what Gridfinity is. All right, basically Gridfinity is a 3D printable generic container template. So it's like a huge project. There are a lot of contributors to it. And what happens is people come and say, you can have screw boxes, you can have screwdrivers, you can have all sorts of equipment. For everything, there is some Gridfinity model. So it's based on a 42 by 42 grid. And you can really build big projects with it, right? So if the thing with Gridfinity is this tries to emulate the thing that you see with tools. So if you see with tools, they are built with the ABS molding. So what really happens, you have a rectangle, inside that you have like a hole in which something sits, right? But with 3D printing, it's vested. Why is it vested? Because you have to print that whole thing to the height. What you really need is something which will hold it, right? And this project is exactly that. It adds extra stuff which just holds the Allen key, and it has like notches where you can actually pull the Allen key out, right? So one sec. I'll zoom it in. I'm not sure if it's clear. I think this will make it clearer. Does that make more sense? So you have like space, you can actually pinch and pull out the Allen key. Okay, so yeah, getting started, we have a page, and let me show you guys something else interesting. So there's a demos directory. Oh, what exactly happened? Oh, it's demo, not demos. Okay. So one thing I'll mention here is another theoretical project right now. So we have a board called FOSSDEM audio board. It's used for audio capture. In the FOSSDEM conference, the largest FOSS conference in, I think, Europe, maybe the world, I don't know exactly. So basically give it this thing and it'll split out the whole thing. But the fun thing is, if you really look at it, let's see if this has those examples. So typically, if you search around online, what people have been doing, they've been building molds like this. Okay, the one which you see below is basically wastable. It's wasteful in terms of the kind of plastic that it takes. Right, it's solid. It has hollow only where the components have to go. Right. With this project, you can build those. Plus, you can build these kind of sparse structures. Okay. So you want to do something industrial, do something which is like, tagda. It's like, it has like, it's big, it's hollow, it has hollow pockets, right? You want to do something for one-off use for like 10 boards or something like that, do something which is sparse. You're in education, you're trying to teach somebody something. Why would you want to sit around printing the whole solid thing and then put cavities inside it, right? So don't do that. Just do this. So that's actually illustrated here. Let me switch off. So when I showed you the Pico, I showed you guys this, right? So basically, if you really use this, it uses this much plastic, right? The other equivalent of this is just this. Oopsie. Can you guys see how that's going to work? Alright, so you're like, take the header. I'm sorry for the shaking camera. One header. Oopsie. Two header. So it's exactly the same thing. Yeah. And it prints very quickly, it consumes very little material, you could build an entire environmental story around it, but I'm not going to do that. Right? And 3D printers are just those kind of people. Hey, let's print the heck out of this, right? So I'm like, no, just think about it. There are plans in the project, by the way, to do like Maybe with origami. So some of you guys may know Amit here. He's very interested in origami. Influenced by him, I bought origami book, which I never read till now. Right? But one day I'll come to it. And I think, for hobbies purpose, there's no need to like 3D print a lot of the stuff. You could do it with origami. Use your hands for something useful, productive, and kind of like exercise your brain also, rather than like control P and send it to the printer. So roughly that's, if you actually go to the project page, you'll find a lot of details, like for example, how much grams of material can you save, what are all the 100 properties, like many things. You can export to OpenSCAD. That gives you a parametric model which you can tweak on the fly using the sliders. So it has like tons of these features which I don't want to go into, but they're there. And most important, I will tell you that I've been doing some commercial projects with this, which has shocked my friends, me also, because the biggest problem with so what's the ultimate use of this? Can this be used in factories, right? So of course, we solder, I don't know, what we solder in 10, in like 1 year, they probably solder in 10 minutes or something like that, right? I have seen them work. Okay. So I was trying to figure out if this can be used in factories. Then I spent time prototyping with a single company which is in Banchankri. It's a single line electronics factory manufacturing. They do a lot of manual soldering, and turns out there are still good reasons why people are doing manual soldering. Depends on the kind of components you have, the kind of volumes. There are like many considerations. So when I showed this to them at one of the conferences, they were just right out. So I was giving a talk, and their booth was right outside my that room where I gave the talk. So they immediately latched onto it. It's a small concern. So I went did a project for them. They were happy, but that project didn't run long. That means that I didn't get much money, right? So then I was a little worried whether this can work or not. Then they came back with another project, which is kind of also start-stop, but at least I'm sure that I'll make a little more money. In case you're wondering what is little more money, it's probably going to be like 60,000 rupees over 6 months. And the biggest challenge with all these people, as you might imagine, any Indian company is like getting the payment. You can raise the invoice. Right? But when will the payment happen? That requires another expert. But regardless, what I will say here is the efficiency of these people has gone through the roof. I am surprised. When an Indian vendor tells you that, Indian customer tells you that your efficiency has increased 30%, you should be sure that it's at least 50 or more than that. Right? I mean, that's exactly how price bargaining, price negotiation works, right? So you ask somebody, how is it? If he says very good, then that means that your value will go up, right? So, so that's the fun thing. But the most unexpected thing for me, out of this project has been, which I never expected. So there are a lot of women which are who are employed in the factories, and they are like, wow, this really works, sir. This is amazing, because they all ultimately they set targets, right? They have to meet targets, and any tools are welcome that way. Ultimately, it shows in their contribution, right? So I did 100 boards today, will become 150 boards tomorrow, right? So they'll, in the beginning, I will get some credit. Later on, it'll be like it's part of the process. So I'm just trying to make it happen that way, but it's fun. I have to still find ways of scaling this, but of course, the entire project is open source. But I have to say this: not every technique I use in the factory floor is actually in this. So it's not exactly open core, but it's like that's the part of the business that I probably understand very well. So when I go work in a factory for like a month or something like that, I probably understand how they work, what kind of structures work better, what materials work better. If they throw solder also on it, will it survive? What material to use, right? So all those kind of things are probably but most of the thing which any hobbyist, anybody doing small prototyping can use this. Industrial, probably like you need something a little more robust than this, which probably I mean most of the thing which is already open source does, like I think 95%. But yeah, but that's the thing about industry, right? It's always about that last thing which makes things work. So I have something which I do as a some code which is not maintained in GitHub, but otherwise is very active. If I find out bugs, I fix them there. So I think how are we doing on time? Oops. So we have 15 minutes. 15 minutes? Oh yeah. Can you pass it around, Shree? Huh? Oh yeah, I can do that. You can take questions. Yeah, I think then this is a good time to. Yeah. Where's the other piece gone? Yeah. So that's okay. Don't worry about it. You can pass this also around. Actually, I have like a whole bunch of whole box if you want. Yeah, here. Just make sure that it all comes back. So this has all the various structures, a lot of things. Yeah, because quite small, right? It's a little harder to show. This also you can.
That was the one that's without
That's
optimization.
yeah, it's not without optimization. Yeah, this is a very similar this thing also. Yeah, it's the same. So that's what roughly the project is. You can use it. I did a workshop on this in one other conference, and the healthy thing that came out of it is I made it work on Windows. So that script is also there. So it can be used. It's still a command line tool. I have a plan to put some front end with graphics, with a graphical front end kind of thing. No, it works with capacitors, transformers, resistors. Yeah. Correct. Generally, what happens is if you know exactly which one it is, you do that. In my case, my work with the factories, you know what happens? I have to reverse engineer the board because they're given the task only of soldering, and they say, "Hey, sir, this is a sample, sir." Right? What do you do on top of that? So then you like quickly figure out what to do. Because they will not have the entire BOM and everything, and even if they had the BOM, those guys won't be maintaining 3D models. Nah? So if it's like 0.2 or 0.3 mm difference, what will finally happen is that everything, the post soldering result will not be that very good. So if it's a first person design, that's always very good. Yeah. One sec, hold on. There's even a mic somewhere, I think, if you want to use it. There's a mic here. Yeah. Sorry. It's sitting right here.
Guys, everyone who took the jig, just pass it over to Harish, please.
First thing, I like the names you give your projects like Jigita and Hativega, and yeah, if I have to name something next time, I'm going to contact you.
Certainly.
So
thank you.
That said, I was about to ask. You said it's a CLI tool, right? So is there any possibility you can make it like a website? You know, like people don't have to download anything; just come to your website, they upload some file, and they.
Yeah. Okay. In fact, quite interesting question. Because when I first showed it to our folks here in Absurd, right, the first question they asked was exactly this. You know, hey, you can make some money out of this. Put this on the cloud. You know, it's not invalid. Probably right, but it's a little more complicated than that because then I have to start. Okay, I'm not a web guy, and you know all that. I hate maintaining that infrastructure. That's one of the things, and I wanted to study the problem from a practical perspective, because ultimately it's not the hobbyists who will pay for this kind of thing. You know, maybe there's some industry. Hobbyists can probably spend some time figuring it out, and that's what I've been doing. I've been prototyping it with the factory, and sometimes nowadays when I attend other events, I go it with the eye to see what are the kind of components that these guys are still using on the boards, which otherwise I'd be thinking, you know, what is the architecture of the board? I'm a very senior embedded systems designer. That's what I would look at earlier, but now I'm looking at what components are used inside the board, how are they placed, right? So I think there is maybe some scope, but the interesting thing is, it's just too much to expect right now that it work out of the box for the ultimate intended user. So for an engineer who's designing their own boards, they already know what is a 3D model and whatnot, right? So then if they make some mistake, they know how to fix it. Right?
Yeah.
But for a generic person, if you provide such an interface, they'll start thinking that no matter what you throw it at it, so the garbage in, garbage out principle they will forget. And they'll blame the tool for a mistake which is not the tool's. So this commonly happens in electronics. People change components, so many things people do, right? And then, I've worked for 12, 13, 14 years with. I have never been a hardware designer myself. I can call myself a hardware designer, but the implementation is always done by very experienced people. So, but they are sometimes very lax about these kind of things. Some of them do it very well, but ultimately, garbage in, garbage out still applies, which is the trickiest thing. So.
Yeah, got it. Thank you.
Any more questions? Okay, we have one there. Okay.
Have you tried it with pogo pins? That's especially useful for testing, flashing, those kind of things.
Aha, great question. All right. Let me think of how to. Actually, some things I didn't show in the interest of making it simple. One of the concepts is basically that you can slice. Think about it, right? So, in a lot of the designs, you have like big vertical thing, and there's plastic in the middle. So basically, there's another mode in which you can operate the program. You can cut the middle, and you can have like screws, and then you can like compress it. So it's already provided for in this tool. It's a very roundabout way, by the way. But that thing that you're asking when the pogo pins will come and press, right? That's already provided for. It already handles mounting holes. It can provide spacer-like mechanisms. Actually, some example might even be floating around in that box. But it's possible. It's not exactly like a directly supported feature, but it's implicitly like built in. So.
And in that case, a follow-up question. In that case, if someone is using pogo pins and a clamp, will the plastic be able to take it?
Oh, yeah, that's all out of the. That's like mechanical design, right? So that's not in the scope of this. It probably allow you for doing variable spacing, and then you put a spring, and you push it in, and you have like a little mechanism. Then it will make contact. So 5. Any more questions? You have one.
Hello, sir. This is a really interesting idea. So I want to ask. You showed two 3D printed boards right now, one for the Pico and one for another board.
Yes.
So I was wondering if it is, so for these boards you have to create that design for each individual board. You would have to create a design. You would have to create a jig for that individually. If you were to
you would have the design as part of the engineering process.
Yes.
Yeah.
So I was wondering if it would be possible to create a sort of building blocks kind of implementation, as in because all the ports and pins are kind of a standard size. So maybe if you could have like a base like for building blocks, and then each port and each pins, like you can create. You can.
Great question.
You can make a lot of. You can do for whatever board you have, right?
Yeah. So, actually, it's a great question. I'll try to put a different spin on this because I have thought a lot about it. 2 aspects, right? For every board, should you have a different jig? Correct? That's your real question. Now, if you really look at it, let's say you're into soldering bug headers, right? Bug headers have certain characteristics, right? They're all like roughly the same height, right? And you'll have many of them in different places. So instead of, actually, I don't have that example. Yeah, apologies. So basically, the idea is that I have it somewhere. I think it's an example. One second. Let me find this out. This is a good question. This is a good question. 1 second. Pico soldering jig. Yes. Oh yeah. Sorry. Oh, okay. Sorry, it's not there. Basically, you have this thing where you can make just a single thing, and you can have a variable height thing, and it be solid. So you can have as many of them placed like a Lego brick. Then you can push it in. So that exists. I am not able to find it now, but it's very much possible, and you can tailor it to the way you want to see it. You say that this is the height that I typically work with, and then you just make one bug header holder, and you can just move it around everywhere. And anyway, fitting it is not a problem, right? So the whole pattern will match. All right. So I think we are out of time. And thank you very much. Any more questions? I am around in the conference. Maybe I'll be busy today, but definitely tomorrow is going to be a relaxing day. So thank you, guys. Done?
Yes. Yes, you can leave it. You can take your laptop, sir.
Yeah.
All right. Thank you, Shree sir. That was a great talk. Like Shree sir said, you can meet him after the talk, and you can connect with him for more questions. Just
one last plug. I don't know, maybe a bad idea for a conference, which I am finding out. So I've been thinking of running a potluck. I think it's still open. I don't know how many people have said they will bring something. Idea is to meet for lunch tomorrow between 1 to 2:30 In that room, like there's a small workshop room upstairs. So anybody interested, I'm not saying, but it's just, that's why I call it it's not shameless in this case, it's a plug, that's all. So if you want to get something, just go to the forum. It's just a side event. If you want to get something, it'll be a fun thing. Let's see.
Okay. Thank you, sir. Yeah, folks. I don't know, clap, I guess. There.